Alright boys, first drive using the Holley and using the TCM 2600 provided by PCS or Powertrain Control Solutions, I believe that's their full name. Anyway, so I ran into some issues initially using PWM versus shift cut as a PWM output. It's based on time, not during the actual transmission shifting period. So when your transmission commands a new gear, like say I'm going from first to second gear, there's an immediate trans slip error because the software wants you immediately to be in second gear, so there's a continuous slip error until the transmission completely shifts into that gear. With these clutch-to-clutch transmissions, it takes a little while. I was seeing, and it depends on the volume, I believe, because it has to fill the oncoming clutch pack before it will actually attempt to do the shift. So it has to fill that volume, and that's your delay that you're waiting on. Unlike a 4L60 or a 4L80, when it commands the gear, it immediately starts the process, and you're just limited by the hydraulic lag or the mechanical lag of the transmission itself to perform the shift. So these transmissions, the 6L80 and the 6L90, are a little bit more sophisticated. And what I'm doing now, and you can see it flashing yellow on the Holley, is that's my trans slip right now. So you'll actually see it turn yellow, go to like a negative number or a positive number, depending on whether if it's an upshift or a downshift. If it's an upshift, it will go to a positive number. And if it's a downshift, it'll go to a negative number. So I set up the Holley to pull timing based on trans slip instead of some sort of time delay system, because I actually want, instead of trying to find the window and get it right, which the window changes based on line pressure, I want the window to be consistent where it's pulling timing to help, keep the transmission alive during 1-2s or 2-3 upshifts. On these clutch-to-clutch transmissions, the 90 is more robust than the 80, but you can definitely have some clutch pack failures in the long run from doing so. So what I'm doing right now, and so far it's working pretty good, other than the transmission still has to keep learning, so it'll stop flaring on the 2-3 or the 3-4, is now that constant percentage that you would see initially was it was like, I think the lowest number I saw was like 25%. So it all depends on how steep of a gear reduction it is. So like a 1-2 is like a 36% reduction, and then it's like a 25 or something like that. I forget exactly how it goes, but I found between 1, 2, 3, and 4, the lowest percentage is like a 25% gear reduction. So what I have this thing doing is I only have it pulling timing on the 20% or below. So it won't pull timing on 25%. You wouldn't want that, because that's when the computer is trying to figure out when to shift. It's not when it's actually shifting. So I have it start pulling at 20%, and it will pull until it gets to 2%. And by then, you got 2% trans slip. You know that you pull torque down during the majority of that actual shift, so that'll help keep the clutch packs alive. There is a function in the TCM 2600 where you can have it trigger or send an output based on a rising or falling wave, and you can set up your percentages that way, but I couldn't get it to work. It just didn't work. I don't know why, but if you tried, I looked at like the code for the transmission file in a hex editor, and I still couldn't figure out why the values, which seemed like they would work fine, don't actually work. But PWM versus transmission slip works. And then for the Holley, in order to determine what your actual slip percentage is, I'm doing The percentage will send out a PWM, and in the PWM you can correlate that to a duty cycle. So the Holley will actually interpret duty cycle as long as you're close to the frequency range. So this is a ground only output, so it'll do PWM ground output. And right now I have a potentiometer going from the battery directly into the Holley wire with a 10K resistor. So that's providing my 12 volt spike, and then the ground is being provided by the PWM signal from the TCM 2600. So right now I have a 2D table set up in Holley, and there's no like direct load percentage or something like that you could use for determining engine load. I'm using fuel flow. I mean, that is a form of load measurement. So fuel flow, I have a 2D table, which I'll show later, but the 2D table has slip percentage on the x-axis, I believe, and then on the y-axis it's gonna be the y-axis is my trans slip percentage, and then it's a timing offset table, and for the x-axis I have fuel flow, and I just have it going between 0 and 500 pounds for fuel flow. My truck at about 11 pounds of boost is like somewhere in the 5s or 600, something like that, for fuel flow. So I figured anything past that, I have it pulling about 35 degrees of timing, tapering down to 20 degrees of timing as it gets closer. And I'm going to play with those settings and get it right, because I want it to work properly, and I want it to do torque reduction just fine. I'm not seeing any flares or anything, wide open throttle, so I know the 6L90 is taking the abuse just fine, and I'm not seeing any actual trans-slip in the gear, so that's good. I mean, like, obviously this is working out quite well. This is just a like factory remanufactured 6L90 that I picked up with a controller for pretty cheap. But yeah, so this seems to be working okay. I've tried it without the torque management, and now I'm driving it around with the torque management. I also have a similar graph for negative slip. So negative slip would be, say, on a power up or on a power downshift. The transmission is going to go into neutral, and when it goes into neutral, it creates a negative slip error. But then the engine revs up, and eventually you'll get a positive slip error if the engine over revs the gear before the gear can engage. So what you'll actually see is a power downshift flare, where the engine will be ahead of where it's supposed to be for the clutch engagement, and then it will engage. Ignore the transmission indicator on the Holley too. That's just not right, and so is speed. I still have to I have to fix the wiring on my zero crossing output. I put the ground into the wrong ground in the PCM, or in the TCM 2600. So yeah, you can see it'll go negative. It pulls timing a little bit, and then it just keeps on keeping on, and it's happy. We'll do a quick little pull here. Yeah, I got to work on the shift tables a little bit, but I mean, it's a work in progress like most things. But that's only, about 10 to 11 pounds. It's like 10.5 pounds of boost. So, but yeah, I mean, so far this thing's working pretty good. I still have to get like the timing dialed in perfectly. The conversion itself from a 4L80 to a 6L90 was actually really easy. I had to the transmissions are fairly similar lengths, but they're not the same. I think the cross member is about 3 inches different. I just made an aluminum bracket to adapt that over. And then for the actual output shaft, I bought a 6L90 express fan output or a slip yoke, I believe is what it was. I could probably put the part number in the description, and that worked quite well. It actually puts the output shaft at about the same exact length as a 4L80 shaft, so that way overall from the edge, from the face of the engine or from the bell housing to the output shaft, it's the same length. And so the drive shaft adaptation was really easy. I had to buy a conversion U-joint for my setup because I have 1350 U-joints on the drive shaft. So I bought it's a 1485 slip yoke, and then I did a 1410 to 1350 adapter U-joint, I guess you'd call it. And you have to shim a little bit, or you have to machine off a little bit on the C-clips, on the circlips for the yokes, or for the U-joint, because it's about 10 thousandths or 1,000th of an inch, something like that. I think it was 1,000th of an inch difference between a 1485 slip yoke and a 1485 U-joint. So that's the correct way to get it, or you can buy thinner circlips and that would work too. So that's how you adapt it over to that 1410. So I did that. That works pretty good. I haven't had any like drive shaft weirdness or anything like that. The truck's lowered 2 inches compared to where it was before. And honestly, everything fit just fine. The transmission is significantly lighter than transmission is significantly lighter, the 6L90 is, compared to a 4L80. It's a little bit, they're about the same size. I mean, I guess you could say like in overall girth, but I do like where the 6L90 is bigger is right around where your transmission tunnel is going to be. So for people who already have a small transmission tunnel, it might not be the best thing for you. Whereas it's in a truck for me, so you know, it's really not that big of a deal. I had plenty of space. I even had room to prop or move the engine up about another inch because I was trying to correct my all of my angles for the drive shaft. But otherwise, though, it's been just fine. Cruising around, everything's been good. The actual HP tuners part of the 6L90 is a complete pain in the ass. There's not a lot of good information out there. There's a lot of contradictory information out there. There's like tables that you shouldn't touch, and then because it'll bug the software, or it won't bug the software, or, you know, I haven't found any. All I have found with my setup is, and there's a road closure up here, 1-lane road, so I have to put the phone down. Yeah, the only thing I have found that is really bad with this setup is the HP tuners. I mean, with a 4L80, you know, you tell it to do something, it'll pretty much do something. If you tell the 6L90 to do it, it might or might not do it. Like, one of the issues I had was shift time. So when I first got this thing set up, I modified my pressures a little bit, like it says to do, you know, oncoming preset, and as well as my actual like line pressure tables, and I left my timing where it was at, and I was expecting like a 0.3 to 0.4 second shift time, maybe even longer, and I couldn't get the thing to shift under or over a 0.08 second shift, like, and that's too fast. I mean, a lot of people have said if you're shifting under 0.2 seconds, then the transmission's not going to like it. And I mean, it felt like I was driving around in a built 4L80. So I reset everything back to stock. I barely touched anything, and I just did a fast adapt before I started driving it, and it's still acting a little funny. I've put some miles on it, and it still acts a little funny on the adaptation or the adaptation. Like, I guess, like, I don't know, it still flares a little bit on the 2.3. It flares on the 3.4. It flares occasionally. I mean, it's not like, and that's just cruising around. If you're putting torque into it, like if you're actually accelerating with a purpose, it's fine. But if you're cruising and you're just trying to go slow, it wants to flare the gears. So I don't quite understand why. VCM scanner is a big issue with this thing. The pressures that are in it are kind of, well, for the most part, they're made up, and the data you're getting isn't really helpful. I would like to see like what my real-time pressures are going on, but they're kind of made up numbers. But I have noticed that one of the issues I'm having is on those 2, 3, and 3, 4 flares, it will pretty much create the right amount of pressure on, like, say, third gear, which is the off-going gear, we'll say on a 3, 4. Gear 3 will hold its pressure just fine until it's ready to do the transition to fourth gear. But what it will do is it will drop that line pressure, or it'll drop that clutch pack pressure on gear 3 off to 0 before it even gets enough pressure on 4 to create the transition. And then the whole thing kind of freaks out because it goes into some sort of, shift flare detection. And then that was my neighbor. The line pressure will go up, and then oncoming pressure will go up because it detects a shift flare, and then essentially it just kind of wigs out. Then it will do the shift, but the shift is a little bit rougher than you would expect because the transmission's just kind of upset, or it's not learning something properly. So what I've done is I've just been putting miles on it and letting it learn, and it does seem to get better and better every time it learns. But yeah, I don't know. I mean, there's gonna be more updates on this. I just figured I'd throw something out there for now to help out. But this has just been an in-car, or an in-truck, I guess, review of the whole 4L80 to 6L90 conversion. I hope this helps anyone that's looking for more information. But yeah, feel free to leave a comment, ask me about it. If you have any questions, just feel free. All right, thanks. Bye, guys.